Okay, good morning, and I do mean morning. When I look at my clock here, I just want to continue on with our last section of the semester, actually, with 7.5, and we are going to graph quadratic functions now. All right, so let's see. The idea here is quadratic functions are in the form of ax squared plus bx plus c, generally equaling 0. And when it's in this form, our equations are going to look like, when they're graphed, I'm going to have basically two kinds of looks. All right, and in the general form of the equation, ax squared plus bx plus c, I can say that if this is positive, then the graph is going to open upwards. Call that concave up. Little information before you even start the problem. The vertex is going to be here, and that's one of the components we're going to need to find for each of the problems that we graph. Okay, if this is negative, if I have a function that's negative, then the graph is going to be concave down, and it may take the shape of this. And what's happening here, then the vertex is going to be at the highest point. Okay, and that's the idea we're going to graph. And so I can say, what are the things that we need out of this general equation? We're going to have to find the vertex. We're going to have to find the x-intercepts. And we'll have to find the y-intercepts. And it looks like, we've got experience with two of these, finding the x-intercept and the y-intercept. And what we don't know how to find is the vertex, and we're going to learn how to do that first. Okay, so given our first example here, what I want to do is I want to take this as the sense of this is A, this is B, and this is C in our equation. And in order to find the vertex, let's do that first. I need to find and ask what is negative B over 2A. The vertex is going to be a single point on the graph, and that's represented by x and y. That is a point on the graph. And then how do I find that? Well, x is going to equal negative b over 2a. Okay, I want you to think about that. X equals negative b over 2a. And when I find negative b over 2a, that's going to be my x component. So I'm going to change this to be negative b over 2a, which is x. I'm going to find y by substituting my value for negative b over 2a into the function itself. So that's like saying, what is f of negative b over 2a? And I will find my y value, which completes my goal of finding the point, the ordered pair that is on the graph that represents the vertex. Okay, so given that little bit of information, let's see. How about negative b over 2a for my x component? All right, and I'm going to put it here. I'm going to put it here and say this is x comma y. And then I'll figure out what is that negative b over 2a, which represents x. Okay, so here's my equation. I got b is negative 6. That's going to be negative 6 over 2 times a. A is 1. And this is going to end up being positive 6 divided by 2, which is 3. So now I've got to find f of 3 in relation to the explanation I gave of my negative b over 2a for x and f of negative b over 2a. And that represents my y. So this is negative b over 2a. It ended up equaling 3. So I can say that my first, I'll rewrite instead of erasing. So now this is going to equal 3, comma, and then f of 3 to figure that out. So I'm going to replace the negative b over 2a with f of 3, because this is what x is. And I'm going to use the 3 and plug it into the original equation. So this means I'm going to make this be, make that be 3 squared. Let's get rid of the ABCs now. And I'm going to write this as 3 squared minus 6 times 3 plus 5. And you calculate that, it's going to be 9 minus 18 plus 5, which will equal negative 4. So this ordered pair now is going to be 3, comma, negative 4. Okay, and that's my vertex. Okay, that's good. Now we'll put that aside somewhere and say that the vertex equals 3, comma, negative 4. Next, I'll find the x-intercept. Let's go down this way. So the x-intercept, what is that going to be? Well, if I have this equation of, let's change colors now, x squared minus 6x plus 5, that equals 0. And I have to find the intercepts. That means I have to factor this guy. And there's 3 ways of factoring now. I could do the, what shall I call, the traditional way by figuring out what are 2 values that multiply to be 5 and add up to be negative 6. I can use the quadratic formula. Or I can use the completing the square, which is kind of a different way of factoring anyway. So I can complete the square. If I'm completing the square, I don't have to find the vertex this way. It's done by a different method. So let's put this in a box and say this is another way of figuring out what the vertex is by completing the square. Okay, so far so good. So let's find the x-intercepts from this equation here. You can always try the traditional way, but a lot of times in this section it's not going to work. So we have to go on to reliable, which is probably the quadratic formula. Okay, all right, and then I'll show you completing the square method as well. All right, so I've got, let's see, I'm going to have a lead coefficient of 1. So that means my 2 parentheses are set up. We know it's equal to 0. And then I'm going to factor that if I can. So I got x and x, minus and minus. And my 2 values then would be 5 and 1. So my intercepts would be when x equals 5 for this one, and for x equals 1 for this parentheses here. And those are my intercepts. So the x-intercepts are going to be 1, comma, 5. And I'll use my squiggly bars here to represent that as solutions to that equation being the x-intercepts, which is 1 and 5. A lot of times we put them in parentheses, and that represents a point. We get confused. Why is that an ordered pair? if I put 1 and 5 in parentheses. No, I'm going to make that as squiggly lines or brackets. You know, I could use brackets too as well. Okay, so I've got that. Now I just need one other thing, which is the y-intercept, which is the easiest thing to find. And to find that, I'm going to let x equal 0. To find the y-intercept, I have to let x equal 0. To find the x-intercept, I have to let y equal 0. Okay, and that's what I've done up here so far. So this one, let's see, I clean this up a little bit so I can see, and you can see better. I have my answer written over here on the side. So this one, if x equals 0, that's going to be 0 minus 6 times 0 is 0, plus 5, that equals y. I'm finding the intercept, so I'm keeping my y, or f of x. Okay, that gets a little hairy too, because, you know, wait, what am I doing here? I put this equal to 0 because I'm factoring this. This, I'm figuring out what the intercepts are. So I let that stay as y, and y equals 5. Actually, y equals 0, 5, technically. And I'll use that as a point and put it in parentheses. So here's my 3 components I need to sketch the graph. Okay, the vertex is 3, negative 4, and that point is plotted here. That's the vertex. It's opening upwards because this x squared is 1x squared, and the 1 is positive. Then I've got my intercepts of 1 and 5. Here's 1, here's 5. Oh, that's really turning out nice. And then I have a y-intercept of 0, 5, which is up here. All right, notice from the vertex, if I draw a line here, not very straight, but this line is called the line of symmetry. And it splits the parabola up into 2. So it's going to be even on both sides. So if I look at this line and this line is going through 3, well, then it's going to be even, and it is even because 2 to the right is the 5 and 2 to the left is the 1, which are the intercepts, and that splits it right down the middle. And that kind of tells you you're doing it right. If it's also true for if I match it and align it with the y intercept. Well, up here, as this graph is widening out, it's going 3 to the left. And so the missing point over to the right would be 3 to the right of this line of symmetry. So I'd have 1, 2, 3. That kind of finishes it off. And now you can see my graph is going to look like this. It's basically a sketch. Nevertheless, this is my answer. And we're done with example 1. Another way of graphing these or sketching these is completing the square. If I complete the square on this, so let's do that. So I'm completing the square, so I'm going to start this problem by subtracting 5 from both sides. And then I'm going to have x squared minus 6x plus what? That equals negative 5. Remember, I'm creating a perfect square trinomial on the left side. That way, when I factor it, it's going to be a binomial squared. Okay, now I'm going to figure out what is the c here. What's the constant of this perfect square trinomial? So how do I do that? I take the negative 6, divide it by 2, and then I'm going to square it. All right, so that looks like it's going to be 9. I'm going to add 9 to both sides. And then this left side is going to be in the form of x minus 3 squared. and that's going to equal 4. Given that, I can look at this now and say that this is in the form that we want, which is x minus h squared minus k. Minus or plus, it comes in both ways. I'll say plus like we do the other ones. Okay, this is in the, what I call the HK form. And from that, I can get what the vertex is going to be. I'll use the numbers here since we've already done it. Okay, I can say that if I could bring the 4 over if I wanted technically, and it would read x minus 3 squared minus 4 equals 0. If I'm getting equal to 0 as well. All right, now the vertex is going to be positive 3 for what's in the parentheses, the opposite of this negative 3. Or I can say, what does x have to be to make this 0 in the parentheses? Well, x would still equal 3. So that would be positive 3, comma, and then this number is as it is, negative 4. And that's the vertex again, solving it in a different way. Going back to this point here, or the original equation, I could figure out the same thing for the x-intercepts and the y-intercepts, which I won't repeat here. We'll find out the same thing. If x is 0, y is going to be 5. Okay, that's the whole idea of completing the square. Maybe I'll do a couple other ones as we go through our examples. All right, let's go on to example 2. All right, we graphed that already. Let me scoot this over. And I've got the same job going on. Here I want to find the vertex. The x-intercepts. And the y-intercept. Well, I can see the y-intercept already. If x is 0, y is just going to be 3. So I'll just jot that down while I'm here. Y-intercept is 3 because it's easy to find. It's like that all the time when it's in standard form. The vertex then is going to be negative b over 2a, negative 2, divided by 2 times negative 1. This negative at the beginning of the quadratic function tells me that the graph is going to go down. It's going to open downward. Okay, so here I've got positive 2 divided by negative 2, which is negative 1. All right, so I'm going to take the negative 1 and plug it right into the equation here to figure out what my y value is going to be to complete my vertex. Okay, so I'm going to have here, and my y value is going to go here after I plug in the negative 1. So this is going to end up being negative 1 squared minus 2 times negative 1 plus 3. And what does that give me? That's going to be negative 1 plus 2 plus 3. And that looks like it's going to be 4. So my y component is 4, and negative 1, 4 is my vertex. Okay. Lastly is the x-intercept. So I'm going to take this function here, and I am going to factor it for the x-intercept. So I've got negative, I'll write this in red, negative x squared minus 2x plus 3 that I'm factoring now. And it equals, I guess it equals y. If I'm factoring this, I'm going to take out the negative to begin with and divide back what's left over, which is x squared plus 2x minus 3. Okay. And when I factor this now, I'm going to, I think I can do it by the traditional way. Remember, I'm discounting the negative, so that's gone. I'm just factoring what's inside the parentheses. So I got x and x. I've got a plus and a minus. And then it looks like I got a 3 here and a 1 here. Yes. So when I solve for x equals 0, all this equals 0, I'm going to have x equals 3 and x equals 1. That's x equals negative 3, sorry, and x equals 1. So those are my intercepts. X-intercept is negative 3, comma 1. Okay, my vertex is here, x-intercept, y-intercept. And now I can drag this out. And given my information is clear, I can plug it in. All right. Let me get a clearer place to place this. It means I gotta rewrote it there, so that's okay. And I'm just finding room to graph this. And I've got it here. And let's do that. So I said the vertex is negative 1, 4. Negative 1, 4 is here. Vertex, it's going to open downward because of the negative here. So that's a check. My y-intercept is 3. And that would belong here. 0, 3, to be precise. And the x-intercepts, we said, were negative 3 and 1. Negative 3 is here. Positive 1 is here. And it looks good. Well, here's my line of symmetry. This y-intercept is 1 unit away from the line of symmetry on the right, so it's going to be 1 unit to the left to complete the graph, the sketch of the graph. And my graph will look like this as you see it. Okay? And that's the graph I'm looking for. Okay, very good. Okay, kind of chuck that a little bit, and here's example 3. Okay, example 3. That's going to equal this 3x squared minus 6x plus 1. Same way. Vertex, x-intercept, y-intercept. All right, vertex. Negative b over 2a. Negative b over 2a. And that's going to give me my x value in the sense that it's going to be x comma y. All right, so my x value will be negative negative b, negative negative 6, divided by 2 times a, which is 3. So it looks like that's going to give me 6 over 6, which equals 1. So my y component, or I'm sorry, my x component is simply 1. That goes here. Now I'm going to find my y component by plugging in f of 1. So f of 1. And when this is 1, then I'm going to end up with 3 minus 6 plus 1, which is negative 6 plus 4, which is negative 2. Negative 2. And that's going to go where this y is. Negative 2. So that's my vertex. Let's find the x-intercepts by factoring this 3x squared minus 6x plus 1. Let's see. How about it? So I'm going to have 3x squared minus 6x plus 1, and I'm going to factor that. And I can use the quadratic formula if I wanted. And if I use the quadratic formula, that's going to be negative b, so it's negative 6 plus or minus the square root of b squared, which is 36, minus 4 times a, which is 3, times c, which is 1. All right, this ends up being 36 minus 12, which is 24. So we're looking for the 6 plus or minus the square root of 24, all divided by what? 2a, which is 6. Okay, so let's simplify this a little bit more. And what can I do? I could say this is 6, and if I do the square root of 24, well, that's going to be 4 times 6. And if I take the square root of 4, I know that's 2, so 2 will come on the outside. I'm going to keep going downwards here with that. So I'm going to have 6 plus or minus, and then I'm going to have the square root of 4, which is 2 on the outside, and what's left is the square root of 6. And that's all going to be over 6. All right, so what I could do with this is I could write the 6 under both of these terms, under this first 6 here, and then under this 2 square root of 6. And if I do that and I split it up, then I'm going to have 6 over 6 plus or minus 2 root 6 over 6. And I can now do what? I can simplify them even further. 6 over 6 is 1 plus or minus 2 over 6 is the part I'm going to simplify. That's 1/3. So that's going to be the square root of 6, and that's going to be over 3. 1 plus or minus the square root of 6 divided by 3. And those are going to be my x-intercepts. Okay, I could write that this is 6 over 6. I could leave it as 6 over 6, but I don't want to because my component here is 3. So I'm just going to leave it as that. So when we're plotting this and want to know where to plot it, I want to figure out what this equals. What's 1 plus the square root of 6 divided by 3? And let's get a number here. Okay, use your calculator, of course. So I'm going to have 1 plus the square root of 6. I'm going to put that in parentheses on my calculator. 1 plus the square root of 6 divided by 3. No, I got to do this the right way. So I've got to do it square root of 6 Yeah, be careful how you put this into your calculator, because it'll give you a different answer. I got two different answers, but the correct answer for 1 plus square root of 6 divided by 3 is going to be 1.8, and the other answer is going to be 1 minus the square root of 6 divided by 3. So let me just put that in as such, and the second answer is going to be 0.18. These are my x-intercepts now. Okay, so here it is here, and I'll leave it here as my x-intercepts instead of wasting time trying to find it, squeeze in a place over here. All right, and the last thing I have to do is find the y-intercept, which should be the easiest thing. And I'm coming back up to the original equation, which is here, and I can see that y is going to equal 1 if x is 0. Okay, so y is 1. That's going to be my y-intercept. And that's going to equal 1, or 0, 1, whichever you prefer. Okay, so let's go plot it now. And my vertex we said was 1, negative 2. Go over 1, down 2. And this is my line of symmetry. And here is my x-intercept. Here are my x-intercepts, 1.8. So that's going to be approximately just short of 2. I'll put that intercept there, and the other intercept is 0.18. I will say, I don't know, 0.2 maybe, and that's going to be here. And finally, the y-intercept we said was 1, 0, 1, which goes here. This is a very tight graph, very close together, but you can see it's going to be this parabola that goes up and out this way too as well. And that's the general sense, or the general sketch of the graph. And we are done. Okay. Here is example 4 coming now, and let's give it a try. And kind of do it. I'll do this one both ways. The completing the square method, as far as the other method, we're going to use that as the graphing the quadratic function in the traditional way, I think. Okay, let's try. We're going to find the vertex. I'll just call it a V, x-intercept, and y-intercept. The y-intercept, I can quickly see it's going to be 0, negative 5. The vertex is going to be negative b divided by 2a. So that's going to be negative 6 divided by 2 times negative 2, which will give me negative 6 divided by negative 4, which simplifies to be 3 over 2. So that is my x value. Okay, if that's my x value, I'm going to plug in 3/2 into this original equation, where it's going to look like negative 2 times 3 over 2 to the second power plus 6 times 3 over 2 minus 5. Okay, you can plug this into your calculator to figure that out. And let me plug it into mine and see what I get. All this turns out to be negative 1/2. Okay. that happens to be my y component. So the vertex is going to be, the vertex then, so it stands out, is going to be 3 over 2, comma, negative 1 over 2. And this is my vertex here. I've got to find now the last thing, which are the x-intercepts, given this function here of negative 2x squared plus 6x minus 5. And I am going to factor this as well. I'm going to use the quadratic formula, so it's going to be negative 6 plus or minus the square root of b squared minus 4 times a, negative 2, that's a, extend that, 4 times a times c, and c is negative 5. Okay, so right away, this is interesting, because what's going to happen here is I'm going to end up with a imaginary number. So this is kind of going to be negative 6 plus or minus. When I calculate this out, it's going to be the square root of 36 minus 40, which is the square root of negative 4. Okay, so now I have an imaginary number. If I have an imaginary number here for my x, remember all this is equal to x. That's what I'm figuring out, the x-intercepts. So x is going to be imaginary. So that means it's not going to go through the x-axis. I'm not going to have a real solution. It's going to be an unreal solution, or imaginary numbers. So this graph will be something like, let's see, from looking at it, here it is here. So my lead term is negative, so that means it's going to open downward. But if it opens downward, then it's going to be below the x-axis, so it's going to look something like this maybe. The line of the graph does not go through the x-axis. Okay, that's really important. Gives you a head start of what's going on with this, make it further your understanding. Okay, so I'm gonna, whenever you run into this, I'm gonna stop. I can't find the x-intercepts because there aren't any. All right, so now how am I going to sketch this graph without it? Well, I'm just going to use the vertex and the y-intercept. I'm going to try that. The y-intercept was 0, negative 5. So if I plot my points, where'd my graph go? Well, here it is. Let me raise it up here some. Okay, give me a second here. Swing this over. Let's see if I can do it from here. So I've got the vertex, which we said, scrolling up here, was 3/2 and minus 1/2. Well, 3/2 is 1.5. So that means if I come here, 1.5 is about here, and negative 1/2, I'm going to go down. So the vertex is like right in the middle of that box. Okay, I'll get rid of this to help us out. All right, that's the vertex. And I don't have intercepts because this is going to open downward. And I only have my y value, which is 0, negative 5. And that's here. If I draw my line of symmetry, I can match up its partner on the other side of the line of symmetry by counting 1.5. So that means 1.5 on either side will put me in this spot here, along with my vertex. So I can sketch this to be looking like that. And that's the sketch of the graph of the problem that we're doing here. Okay, so remember this part of the problem, whenever I have a negative square root, it's going to be an imaginary number. So you stop. You can't find the x-intercept. All right, and that is example number 4. Okay. Number 5 is our story problem, our application problem. All right, let's try this. We're not afraid of these because they're going to provide us with the information we need to. Either they're going to give us the quadratic function, or they're going to give us components of it that we can blend together. All right, but for right now, a company selling copies of an accounting program for home computers finds that it will make a weekly profit of P dollars from selling X copies of the program according to this function. How many copies of the program should it sell to make the largest possible profit? And what is the largest possible profit? All right, so here's a preliminary information. Here's a graph, and we know this is the x-axis, this is the y-axis. So they're asking us to find, let's see, let me find it again. Finds that it will make a weekly profit of P dollars from selling X copies of the program. So this isn't Y, this is going to be P. P dollars. And from selling X copies. So this graph looks like, since it's negative here, it's going to open downward again. So that means the maximum profit is going to lie here at the top of the parabola. And these are the X values here. So when it gets to this point here, that's going to be the number of copies of the program that you sold. And the total number of dollars you're going to get is the P value, or I could say the Y value, which comes from the top of the parabola. And this is finding the vertex, is all we have to do. How many copies of the program should it sell to make the largest possible profit? And what is the largest possible profit? So we're going to find this point here, which is the vertex, which is negative B, which is negative 27, divided by 2 times A, and A is negative 0.1. Okay, and that's going to be negative 27 divided by negative 0.2, which is going to equal, what is it going to equal? 135. Okay, so this is my X value in my ordered pair. That'll be my vertex. All right, so I got to plug in 135 into the original equation. So that's going to look like this. Negative 0.1, 135 squared plus 27 times 135 minus 500. And if you're going to plug that into your calculator, which I have done, that gives me a value of $1,322.50. And that's going to go, didn't give myself enough room. It's going to go here, 1,322.50. Okay, so this is telling me now that you got to sell 135 copies of the program, and the maximum profit you'll make is $1,322.50. And that's it. That's all we're doing with that one. No graphing, just answering the question. By finding we're finding the vertex on these problems. How about example 6? It has to do with revenue and cost and profit. So this is all about an art supply store finds that they can sell X sketch pads each week at P dollars each. According to the equation, X equals 900 minus 300P. Graph the revenue function, R equals XP, so the revenue of P is going to equal X times P. Then it says graph the revenue function R equals XP. Oh, graph the revenue function. Then use the graph to find the price P that will bring in the maximum revenue. Okay, finally find the maximum revenue. All right, so what is going on here? I've got X equals 900 minus 3P. And then in my revenue function, it's X times P. I don't have anything that says what P equals. So X equals 900 minus 300P. And that's this X they're talking about. So I'm going to write this up as 900 minus 300P. That's what X is, times P. I'll write it up this way. And if I distribute the P, then that's going to give me 900P minus 300P squared. And this is my quadratic. Of course, this equals R of P. Okay, this is my quadratic function. I'm going to flip it around so I'm in descending order with my powers. So this is negative 300P squared plus 900P. Now I have a quadratic going. I've got A here, B here, and C we could call 0 if we wanted to. Okay, now with this information, I want to take this information and plug it in to find my vertex. Okay, so that's negative B over 2A. And then F of negative B over 2A. Okay? Negative B over 2A. I got negative 900 divided by 2 times A, which is negative 300. And that's going to end up equaling 9 over 6 or 3 over 2. So 3 over 2 is one component of my vertex. And now I got to figure out what is the y component, if you will. And I'm going to plug in 3/2 into the original equation. And the original equation was, I guess, well, I could call it this one. Okay, what will it look like? So I'm going to have 900 times 3 over 2 minus 300 times 3 over 2 squared. And I'm going to use my calculator to figure that out. And I get 675. All right, so that's my value for y is 675. And if you graph that, and how am I going to graph 675? So you've got, what have you got here? I'm going to have, let's see what kind of picture they got here. You can look at the graph of, you can look at the graph and find it there on in example 6. I don't have to redraw that. That's a nice picture they have of that. And it is 675 is the maximum revenue. And it is obtained by setting the price of each sketch pad to be $1.50. And that's what 3/2 is. 1.50, that's the sketch pad, and it's going to generate $675. Okay, that was the last one.